Hi there. With my first attempt at WRO2023, I just managed to get inside the 2-minute time limit. I thought this was quite good, but then thought maybe I can improve it. With various changes to the strategy and the robot, I got the time down to 90 seconds. Then I heard about other ideas which gave an even faster time. With a more radical change to the strategy, I finally got the time down to 68 seconds. In this video, I will start with the 2-minute robot and then explain how strategy changes and the corresponding rebuild of the robot got the time down to 90 seconds and finally to 68 seconds. The 2-minute robot uses ports A and B for the movement motors. Ports C and D are both line follower sensors, so the robot can follow the middle of the line. Port E is the motor which grabs the containers and the boats. Port F is for the color sensor. This robot can follow lines in the forwards direction only and can read the color of the marker blocks as it passes them. It has a ship grabber and a container grabber, both driven by the same motor. Now let's speed up the video and think about what we can improve. Reading the marker blocks works well, but only being able to line follow in the forwards direction is a disadvantage. The robot has to reverse up to containers to grab them. This reduces the accuracy of the positioning. To overcome this, I used the crossroads in the middle as a reference point. Before grabbing a container, the robot drives forwards a short distance up to the crossroads to fix its position. This obviously takes time. Line following in both directions would be faster. There was also a reliability problem with dropping the containers onto the ships. The success rate was only about 2 out of 3. The 90-second robot focused on 3 improvements: better dropping of containers, line following in both directions, where possible increased movement speed. To line follow in both directions, the robot has to have a light sensor at the front and the back, as we see here. It will now follow the edge of the line and is offset so the robot remains central. The port connections are the same as for the 2-minute robot. The line follow sensors just have different functions. Being able to line follow in both directions makes it possible to choose a shorter path to complete the task and to move around more accurately. The boat grabber is similar to the 2-minute robot, but the container grabber has been redesigned. As before, both grabbers are driven by the same motor. The 2-minute robot grabber moves down to drop the container and touches the boat. The 90-second grabber opens sideways, which gives a cleaner drop. Both grabbers use the classic grab and lift mechanism, but the construction is slightly different. Here we see them working side by side. The 90-second version gave better results. Now we can let the 90-second robot run through at double speed and consider how we could make it faster. We could perhaps win a few seconds by moving as fast as possible, but it is already close to the maximum speed. The distance travelled can hardly be reduced. I think this is already optimized. The only possibility is to try to carry more containers at the same time. This will reduce the distance to travel and give a faster solution. To do this, we will need another motor to drop the containers. This will leave only one sensor for line following. We will only be able to line follow in one direction, but a solution should be possible. The port connections for the 68-second robot will be a bit different. We now have only 2 light sensors, but an additional motor to drop the containers onto the boats. The robot has a slide on its back, which carries the 5 containers, seen here from various angles. The containers are lifted onto the slide by the grabber, then they slide down ready to be released one at a time by the dropper mechanism. The same motor drives the boat grabber and the container grabber. Here we see the container grabber in slow motion. It lifts a container to the slide and releases it when it grabs the next one. The container dropping mechanism has to release one container at a time. When a container is dropped, the next one is held back to avoid dropping 2 at the same time. Now let's run through in real time. First we read the marker block colors and fuel the ship. Then we drive past the 4 containers and pick up 2 with the same colours as the marker block. We pick up a white container followed by the remaining green and blue ones. All 5 containers are now on the robot in the right order to drop them first on the large boat and then on the small one. We first move the large boat over to the crane and hang up the red container. It is safer to keep the containers on the robot. On the boat they could easily fall off. We then drop the 3 containers onto the large boat and turn to follow the line over to the crossroads. We grab the small boat, then line follow out to the sea and release it. We drop the remaining 2 containers and head for the finish. Well, I hope you found that interesting. I think it will be possible to win a second here or there, maybe get down close to 1 minute by driving faster, possibly. If you stayed to the end of this video, I'd be very pleased if you'd subscribe to my channel. Thank you very much.